Right, here we go. Hi everyone. Hope you are all managing at the moment. I'm not going to lie, this is about my, I would say, 15th time at attempting this. Between little people running around the background and just not having a clue how to use the software. Anyway, let's get going, and hopefully, fingers crossed, this one actually works. So we are skipping forward to processes of coastal erosion. What we've done so far is the keywords, the two different wave types, and an explanation of wave refraction. So this is the first main process that we need to look at, and we're doing this first because this is the process that they're going to be examining for your fieldwork whenever we get around to doing that again. So coastal erosion is basically the wearing away of the coastline by the pairs of the waves. So remember the difference between weathering and erosion. Weathering wears away the rock, but erosion removes the broken down material. So in this case here, it's the wave action that wears away sediment and rock from the coastline, but removes it through the waves. So there are 5 different types of coastal erosion: hydraulic action, abrasion, air compression, solution, and attrition. The first 4, you'll notice, all say breaks down the coast. So hydraulic action, abrasion, air compression, and solution all involve erosion of the actual coastline or rocks at the coastline. The 5th one, attrition, just breaks down the load being carried by the waves. So the waves are carrying pebbles, they're carrying rocks, they're carrying smaller sediment. When they're being carried by the waves, that's all being tumbled around, they're bashing off each other, and it's making the sediment smaller and it's making them more rounded. So that's why if you're at the beach and it's a pebble beach, the pebbles are smooth and they're rounded, and that's through the process of attrition. So just important to note that the first 4 involve breaking down the coastline, and the 5th, attrition, only involves wearing down the material being carried by the waves. These processes are really, really important to understand and to be able to explain, because they will form a good chunk of an essay you will potentially be writing in your leaving cert. So I mentioned to you last week that this is one of the questions that comes up frequently. So the landforms or features of erosion that we're going to be focusing on are cliffs and bays and headlands. So for example, when you're describing the formation of a cliff, you will have to talk about these lads here, these 4 different types of erosion, and you'll need to be able to explain them. So in a 15 SRP essay about the formation of a coastal landform, quite a significant number of the SRPs will be made up by discussing the processes of erosion and how they work. So let's go through those very quickly. If we use this diagram here, so this is the coastline, here's the waves. So the first type of coastal erosion is hydraulic action, and that is basically the power of the waves pounding or bashing against the coastline. Now erosion is going to happen more quickly where you've got cracks like this in the rock. So sedimentary rocks with joints and bedding planes will be eroded more quickly than, for example, metamorphic rocks. So in hydraulic action, every time a wave breaks, it'll bash against the coastline. Obviously, if they're high energy destructive waves, they're going to have more power than low energy constructive waves. And during storms with this high winds and that energy is transferred to the waves, there's as much as 25 tons worth of pressure being put on a square metre of rock. Now, to put that in context, an elephant probably weighs, well, I don't really know what an elephant weighs, say maybe 6-7 tons. So if you think about it, that's the same power. One wave is the same power of 4 elephants being flung against a metre of rock, so that's quite significant. So hydraulic action can remove pieces from the coast basically through wave power. The second one then is abrasion, and abrasion involves the waves using their load. So you'll see down here, all of the waves are carrying pebbles, they're carrying sediment. When that is flung against the coastline, then that sediment or those pebbles can scrape away and they can weaken the coastline and cause erosion that way. The third one there is air compression. They're calling it hydraulic pressure here. This is probably the most difficult one to understand. But if you can imagine, so if you look at this little section here, that before a wave breaks, there's air between the wave and the cliff face, or between the wave and the coast. When that wave breaks onto the coast, that air has to go somewhere, and it tends to go into cracks. Now there's no crack there, but if we pretend that it's going in here, and that air, when it goes into the cracks, will be compressed so it fits into the crack. Then when the wave retreats and goes back out again, the air can escape from the crack and it expands rapidly. The next wave breaks, forcing the air into the crack. It compresses, wave retreats, the air expands. So this continued compression and expansion of air can weaken the rock around it and can cause cracks to get bigger and then eventually parts of the cliff to fall away. The fourth one there is solution, and you'll see that up here under chemical weathering. So in terms of solution, best example is carbonation. If you have a limestone coastline, calcium carbonate mineral can be dissolved, but this also goes for other rock types. So solution occurs where the waves, they might be slightly acidic, are dissolving minerals in the rock, washing the minerals away in solution. Final one there is attrition. So in attrition, all of these little pebbles are bashing off each other, they're wearing each other down, and they're making each other smaller. So they are the 5 processes. Salt crystallization is here, and that's there because cliffs can also be weathered, note weathered, not eroded, by salt crystallization, although it shouldn't be under the heading of chemical weathering. It's actually mechanical weathering, but you all know that already. So if you then have a look at the bottom of page 23, you'll see the different factors that influence the rate of erosion. Strength of the waves, so this will depend on the fetch and the wind, the shape of the coastline, if it's indented or straight, the slope of the shore, so this basically would refer to this line here, okay. If it's gently sloping, so if it's coming at an angle like this, the waves will break further out, which means they mightn't get access to the coastline. If it's steeply sloping, then they won't break till they're closer. So in a gently sloping coastline, the waves will break further out. They'll have less energy by the time they reach the coastline, and they will be less erosive. The geology, I've spoken about that already, whether or not this part of the coastline is made up of resistant rock or of softer rocks. So granite will be less likely to be eroded than limestone. And then finally, human activity. So what are humans doing to prevent erosion, or what kind of building work is happening in terms of that. Right, next one then are the different landforms that you need to know. So these are all landforms of coastal erosion. Cliffs and wave cut platforms, bays and headlands, caves, blowholes, sea arches, sea stacks and geos. Of these, the main ones are cliffs and bays and headlands. These are the 2 that you'll be writing essays about. When you're writing an essay about them, you need to be able to stick to need, name, explain, example and diagram. And it's the explain part here which will involve the processes of erosion. So in this bit here, you'll be talking about hydraulic action, abrasion, air compression, solution, or whatever are the best ones that suit. But I will come back to that afterwards. This video I will post separately on the page, and you need to answer the questions on page 24 of that. Right, if there's any questions about any of this, read through page 23. If you still don't understand any of the processes, then drop me a line and hopefully I can make sense of that for you.